Hi everyone, today I'm going to be talking about how academic language and differentiated instruction looks like in math and what Zweyer, Crawford, Tomlinson, and Schmoker have to say about it. Another thing I do want to talk about was this conference that I attended on Saturday, which was really helpful. And they talk about making math meaningful with making math debatable, recognizing students' misconceptions, and reducing math anxiety. So first, Zweyer talks about making effective conversation. So going past surface level conversation. And one of the ways that I kind of related it to was to making math debatable, which was how Chris Luzniak was one of the speakers at this conference where he talked about how making math debatable it satisfies one of the common core, which is constructing viable arguments. And he also noticed that by making math debatable, he saw that the shy students that they really didn't like to volunteer were like talking more. Making math debatable also gave students the opportunity to have a voice. It also helped them to use the academic language. So instead of just showing them a graph and finding what, or even like a shape or a polynomial, and finding all these terms like leading coefficient or exponent, actually giving them the opportunity to use the words. Or even another thing was that Dan Meyer, one of these speakers, he talked about instead of giving them to telling them use this grammar, doing an activity with it. So instead of so for example, he said instead of saying putting a 2 over the x or a little number is on top of the x, actually like having students say like, oh, I want to use a specific word. For example, oh, it's exponent. So like having one like stop saying like that now. Use the words that we created. So actually like promoting academic language. Another thing Zoyer talks about is making powerful prompts and also creating open-ended prompts, which is what making math debatable in essence it does that. So for example, for this one, which is what we're doing in my class, is solving systems. It's like is the blank is the best method for solving the system. Like there's no right answer, but it can either be substitution, graphing, or elimination, where students have to say, my claim is that graphing is the best method for solving the systems because you can tell where the lines intersect. And my claim is that, or they can say, my claim is that graphing is the best method for solving the system, and my warrant is because I'm a visual learner. I can see how the lines intersect. So she also talks about providing choice and ownership. So again, having those like debatable activities gives students the choice of how they shape and direct the conversation, and also like reflect, because the student can see it a different way than the other student, not just telling them it's one way. This is a thing Joe Bowler was talking about. Really famous math educator was talking in her talk about math anxiety. Sometimes we implicitly tell students this is the only way to get there, but no, there's other different ways, and this it kind of reflects back onto promoting differentiated instruction, because she noticed that most of the girls in math, they're really close up, or they create these bubbles because they feel like they don't have a voice, or they feel like the boys are doing it more quickly than they are, so then they just automatically like stop. The math anxiety stops, and they feel like they're not part of the math classroom anymore. So one of the things they talk about is really stopping that message, that speed. In essence, it's what makes you a mathematician in these classrooms. Chapter 5 talks about, again, creating these upper level conversations with the students, posing thought provoking questions, like probing questions to our students. Chapter 6 talks about grammar and vocabulary. through conversation. Another thing that was Chris Luzniak was doing was a going further activity, or it was debate cards where we had students rephrase what the student before them said, and then adding on to it. Another thing that Schmoker talks about in the reading is that we need to make math more meaningful, so it needs to apply to the real world. And he also provides 3 R's, which was closed reading, writing, and again creating those authentic tasks. And when he talks about writing, I kind of reflected back on this graphic organizer that we saw on Saturday. This last Saturday, where it was, for example, the prompt here was combining like terms is the first best step in solving this this equation here, where students can either debate, well, you can either combine like terms first, or they can argue adding 8 to both sides is better, and they have to write it out. He also talks about close reading, which is having students, so it talks about how students are having a very, very difficult time with word problems. So close reading would help them decode those word problems. It's something that I tried with my class when we were doing word problems on solving systems. For example, it said L has twice as much, she's twice as older than her sister. So then I would have students say the word twice and older, because that would mean 2 times S. And also would have them say L and her sister, because those would be my variables, E and S. So having students decode word problems is something Schmoker puts an emphasis on. He also provides a few examples of authentic tasks to use with the students, so kind of relating it to the real world. And it's also something that Joe Bowler kind of touches, which he talks about data science and the difference between data science and statistics, where she gave us this beautiful chart where she said, so it was a bar graph where you had calculus was like a really low bar, algebra was kind of medium, and then all the data science. So having students recognize data and interpreting data, which was data science, which this is a type of math that most students see after passing high school. Like they don't really see, there's not really a lot of applications in calculus. So for example, if they learn about like derivatives, it doesn't really apply they won't really need it in the real world. It's not authentic enough. It's not about making the connections, but about them utilizing it in the future. Then Tomlinson talks a little bit about differentiation. So he talks about managing a differentiated classroom. So creating an acceptable level of buzz in the classroom, which is something that I want to replicate, or I'm working on with my guide teacher, which she did it wonderfully last Friday, where we had half the students working on Kahoot and half the other students working on this worksheet that they were behind on. But I did notice that the students that were working in Kahoot, they were getting a little bit rowdy, a little bit loud, like, oh, number one, like trying to be number one, which she was actually able to like manage them, like, okay, come on, we still have students in classrooms around us, and we gotta make sure to reduce the noise level. Another thing that I talked about was Brandon's table. So I have a student that prefers to work alone, so he does work in his own at his own table, and I also have to make sure when I have her around to make sure if he has any questions. But I do take into consideration when we do have like pair activities or group activities. Like for example, when we had a scavenger hunt activity, I had him sit down with the group that he's more comfortable with and would create less of a distraction. So creating those effective groups. Another thing Tomlinson talks about was creating opportunities that apply in a meaningful way. And one way I would do this is, again, back to kind of making math debatable by using always, sometimes, never statements. For example, alternate exterior angles are always congruent, or are alternate exterior angles are congruent, and then students will argue, is that always, um, sometimes, never true? So giving students the opportunity to use academic language to decode and solve these problems, and they're applying it in a meaningful way. Okay, and then we also talk about grades and teaching understanding in academically diverse classrooms. So it talks about creating effective essential questions. So essential questions that tell students, where they're going to and what kind of vocabulary and grammar they're going to be utilizing. Another thing I want to talk about was that math anxiety that Dan Meyer and Joe Bowler talk about, which was that students have this math anxiety based on speed. And think about the math classroom as a clubhouse where we have a list of people that are in it, a list of things to get in, and a large list of things that ban you. And we're kind of like implicitly telling students in math that if you don't get the question right, like quick enough, because you notice that most of the class around you's already got it and you're still behind, that you're out, that you automatically get banned of the math classroom. So a way he reduces that is, again, by creating these authentic tasks that promote academic language while still not letting students like fall behind or not leaving anyone behind. And he does that with a type of math debating game, which was the which one doesn't belong, and he kind of models it with us. And one of the, for example, he does call on somebody and they forget what they're gonna say. So he does use that. All right, he uses a callback. So he says, "All right, I'm gonna come back to you," and then he later comes back. And so if he would have just like totally dismissed it, that student would have like, or in a class, that student could have just gotten like super anxious and like given up. But giving them that opportunity to try again, and also that activity, it's a content area activity, so it promotes that academic language. So, for example, in that one it was numbers. So if I were talking about prime numbers, the goal was for 7 was not doesn't belong because it was a prime number compared to the other numbers. Thanks for listening.